Introduction. Hello friends. Today we are diving into the fascinating world of cosmic mysteries. Our universe is huge and scientists still haven't solved many of its mysteries. In this video, we'll talk about 5 phenomena that boggle the mind. We'll start with the Great Attractor, the mysterious force that beckons entire galaxies. Then we'll tackle the Fermi paradox. If there are so many stars and planets in space, why haven't we found aliens yet? We'll talk about Kessler syndrome and how space debris threatens our space missions. Then we'll dive into the mystery of the cold spot, a region of the cosmic microwave background where temperatures are abnormally low. Finally, we'll discuss how time slows down near black holes, changing reality itself. Ready to embark on this cosmic journey? Let's get started. Part 1. The Great Attractor. So, what is the Great Attractor? Imagine that huge galaxies, including our Milky Way, are attracted to an invisible point in space. This spot is about 250 million light-years away in the constellation Centauri, and it has been named the Great Attractor. Scientists have noticed that thousands of galaxies are moving at high speeds toward this gravitational center. But what exactly is there is still a mystery. Because of our galaxy's clouds of dust and gas, it's not easy to study this region. The Great Attractor hides behind the avoidance zone, a region we can't see in visible light. However, using infrared and X-ray observations, astronomers have been able to determine that something very massive is there, perhaps a cluster of matter the size of thousands of galaxies. It is speculated that there may be a giant cluster there that is affecting the surrounding galaxies with its gravity. Some scientists believe that the Great Attractor may be part of an even larger structure, the Laniakea supercluster, which includes our Milky Way. If so, we live in a gravitational flow that pulls us toward this mysterious object. The Great Attractor remains one of the major mysteries of modern astronomy, showing how much we still have to learn about the universe. Part 2. The Fermi paradox. Let's talk about the Fermi paradox. Is there other intelligent life in the universe? Scientist Enrico Fermi asked a simple but very important question. If there are so many planets and stars in the universe, where are all the aliens? After all, it is logical to assume that at this scale there must be life, perhaps even intelligent life, in some corner of the cosmos. However, despite billions of stars and planets, we have found no evidence of alien civilizations. One explanation is that cosmic distances are so vast that even advanced civilizations cannot reach each other. Perhaps the signal we send or receive just doesn't have time to reach each other. Another hypothesis states that aliens may not want to make contact with us. Perhaps more advanced civilizations consider us a young race or prefer to observe us from a distance. There are darker theories. For example, every advanced civilization may have destroyed itself before it could even get beyond its planet. Perhaps there is some kind of cosmic filtration that only a select few pass through. We may be one of the few who have passed through this filter, or on the contrary, have not yet reached the point where danger awaits us. There are other theories, for example, that aliens are in forms that we simply can't see, or that they may inhabit spaces we don't yet know how to explore. Whatever the case, the Fermi paradox continues to preoccupy the minds of scientists and ordinary people alike, asking the question, are we alone in the universe? Part 3. Kessler syndrome. Now let's talk about a problem that could seriously affect our future space exploration. Kessler syndrome. There are a huge number of satellites orbiting around the Earth, and among them are dysfunctional, damaged, and obsolete satellites. When they collide, they create debris that can hit other satellites and create even more debris. This is what Kessler syndrome is, a chain reaction where collisions create more and more debris. Space debris becomes a serious problem because its speed can reach 28,000 kilometers per hour. Even a small piece can damage a satellite or the International Space Station. In 2009, for example, 2 satellites collided, adding thousands of pieces of debris to the orbit. If Kessler syndrome worsens, the orbit could become too dangerous for new missions. Scientists are already working on solutions, from using nets to catch debris to using lasers that can destroy the debris. But cleaning up space is the complex and expensive task, and it's one that humanity will have to seriously tackle in the coming decades. Part 4. Cold spot in the cosmic microwave background. In 2004, scientists discovered a strange anomaly in the cosmic microwave background, the so-called cold spot. This microwave background is an echo of the Big Bang, a kind of thermal radiation that fills the entire universe. But in a certain region, the temperature was much lower than expected. This region, called the cold spot, is in the constellation Eridanus and remains unexplained. One suggestion is that it is a super void in space where the number of galaxies is much lower than usual. But there are also more exotic theories. Perhaps it is a trace from the interaction of our universe with another parallel universe. The cold spot is not just an oddity. It can tell us about the very structure of the universe and even what lies beyond it. Although these theories have yet to be confirmed, the cold spot remains one of the most intriguing phenomena that makes us wonder about the diversity and mysteries of the cosmos. Part 5. Time dilation in black holes. Black holes are some of the most mysterious objects in the universe. Their gravity is so strong that not even light can escape from them. But beyond that, they affect the very passage of time. The closer an object is to a black hole, the slower time goes for it. This effect is called gravitational time dilation and was predicted by Einstein. Imagine that an astronaut is approaching the event horizon, the point beyond which light and matter cannot escape from a black hole. For him, time slows down, and from his perspective, minutes or hours pass, while years or even centuries may pass for an outside observer. This effect has been confirmed by observations, and it shows how gravity can change space and time itself. Time dilation in black holes is one example of how extreme conditions can change the laws of physics we are used to seeing on Earth. This effect helps us realize how amazing the universe is and how much we still don't know about it. Conclusion. Today we touched on 5 great mysteries of the cosmos that remain a mystery to us. The Great Attractor beckons galaxies toward us. The Fermi paradox reminds us of the search for alien life. The Kessler syndrome reveals the risks associated with space debris. The cold spot raises questions about parallel universes, and black holes teach us that time and space can change. Perhaps one day we will discover all the mysteries. But for now, keep learning, exploring, and marveling.